All right, Prop 48 says, if in a triangle the square on one of the sides be equal to the squares on the remaining two sides of the triangle, the angle contained by the remaining two sides of the triangle is right. So this is sort of like the reverse direction of Prop 47. So the Pythagorean theorem, which is what's Prop 47, the Pythagorean theorem is an if and only if statement that a triangle is right if and only if a squared plus b squared equals c squared. So in Prop 47, we sort of did the forward direction. We said, all right, assume a triangle is right. Now we want to show a squared plus b squared equals c squared. Now we're going the other way. Assume that we have a triangle where a squared plus b squared equals c squared. So in other words, the square on AB plus the square on AC is equal to the square on BC. Then, assuming we have a triangle that fits those conditions, that triangle is right. So that's kind of what we're proving here. That's what Prop 48 is going to prove, and this is the last proposition of Book 1. Wow, we made it. At least through Book 1, which is not to say we've really only kind of scratched the surface of the elements. We have a long ways to go. Okay, so let's do this thing. All right, so proof. We'll just first write out what I'm assuming. Assume that, how should I write it? I guess I'll write it sort of in the way that the language that Euclid would have used. So assume the square on BC is equal to the sum of the squares on AB and AC. And we want to prove then that angle A, or angle CAB, is a right angle. Okay. So how do we do that? We're going to, first of all, construct AD, and I'll say opposite B. So we're going to construct AD such that AD is perpendicular to AC, and the length of AD is equal to AB. So I think there's really kind of two. It's not cited in here, but I'll cite it, even though it's kind of back from the beginning. Well, making AD equal to AB, that's not hard. That was like Prop 3. Drawing perpendiculars, though, let's see, Prop 11, to draw a straight line at right angles to a given straight line, yeah. So that's, I guess I'll just say it's Prop 11 and also Prop 3. No big deal. Okay. So we'll do that. I think the way I'll do it is I already set my compass to be equal to AB, so I'll just make a little point here to indicate where it should come out to. There. And there's also going to be join AC, CD. I actually wish I would have made that dotted. Oh well. It's too late now. I don't want to go back. There we go. Yeah, would have looked better if it was dotted, I think. It's fine. Those are supposed to be the same triangle. They're close. Yeah, they're close enough. Whatever. All right, join CD. Yeah. Right. Then what do we have? Since DA is equal to AB by construction, so by construction, DA is equal to AB. It follows then that their squares are equal. dA squared equals AB squared. So then let the square AC be added to each. AC squared plus DA squared equals AC squared plus AB squared. Right, so therefore DA and AC, the squares on DA and AC are equal to the squares on BA and AC, but the square on DC is equal to the squares DA and AC because DAC is right. So since triangle DAC is right, we get that AC squared plus DA squared, yep, is equal to DC squared. Yep. That was Prop 47. It gives us that. Okie dokie. And the square on BC is equal to the squares on BA and AC by the hypothesis. So by assumption, we have that AC squared plus AB squared equals BC squared. Well, that means then that since AC squared plus DA squared equals AC squared plus AB squared, we get that DC squared equals BC squared. Moreover, then, DC equals BC. Well, what do we have then? Since AB equals AD by construction, AC is common, we get the triangle ABC equals triangle ADC by Prop 8, because that's side, side, side we just showed. Well, if that's the case, then angle, how should I say? I guess I'll say BAC equals angle DAC. And by construction, angle DAC is right. Yeah. And that was what we needed to prove. So angle BAC is a right angle, just like we suspected. We already knew that. You didn't really need me to prove that to you. You knew it. There we go. QED. Therefore, etc. I'll see you in book 2.